Solving by factoring here just to get started here. Everything's equal to 0. We're trying to figure out our answer. 7x squared minus 3x equals 0. If I want to factor that thing, what do you notice first about that setup? They both have x. So if they both have an x, if you have a GCF, a greatest common factor, something that everything shares, take it out. So they all have an x. I'm going to take an x out. Then I'm left with 7x minus 3. Once I've done that, then I'm just setting each thing equal to 0. So x equals 0, and 7x minus 3 equals 0. 7x equals 3, x equals 3/7. Boom, boom, done. Going on number 1. Number 2, we're factoring x squared minus 5x plus 6. This is the one that kids make a mistake on the most. Double check, okay? Students will either say it's 2 and 3, or it's 6 and 1. Just make sure you pick the right one here. Luke, what do you think here? How can we factor this thing? X minus 3, x minus 2. Just double check them. Negative 3 and negative 2. Yep, I multiply that together. It gets me positive 6. When I add them together, it gets me negative 5. Okay. Sometimes kids will pick this one because you'll see x minus 6 and x plus 1. And you're like, oh, yeah, that adds to get me negative 5. But the problem is it multiplies to get you negative 6. So it's the one that kind of throws you off. All right, so Luke factored it for us. Then all we have to do is solve them. X is equal to positive 3 and x is equal to 2. Then we get into number 3. Number 3 is everybody's favorite. Can I take out something that they all share? No, you wish you could, but you can't. This is the one time where you have to do something different. I'm going to show you how I do it. If you don't like it, don't do it. Okay? I do what's called borrow and payback. If I'm factoring and there's a number in front of everything else, I'm going to do it a little bit different. Okay? Some people do guess and check. I hate guessing in math class. I would much rather have a system of things to do. So here's the best way for me. Okay? If you have a number in front that's not 1, I'm going to borrow that number and multiply it to that last number. So I'm going to change the problem. X squared plus 7x minus 8. I borrow that 2 and I multiply it. Once you borrow it, then you just factor like normal. So I need 2 things that multiply to get me negative 8 and add to get me 7. Thanks for the responses. X plus 8 and x minus 1. You agree with me on that? That's going to multiply. Yeah, good. We borrowed in the beginning. So we borrowed that 2, we factored it, and then you have to pay it back. So if you multiply randomly in the problem, what else do you think I have to do now? Divide. I multiplied by 2 at the beginning. Now I'm going to take both of my answers and divide them by 2. And so my final answer here is going to be x equals negative 4, because 8 divided by 2 is 4, and then I got to set it equal to 0. And then x is equal to a positive 1/2. Okay, it's an easier way to do factoring. You can do it the other way. That way works too. Does that make sense? Okay. Borrow and payback. You don't have to do it. If you got a guess and check method, do it. But if you borrow that number and then just factor like normal, just don't forget to pay it back. Because kids do this right and then you forget to divide. It's not that easy. You got to divide in the end. Number 4, what do you notice first? All x's. So take an x out. So then I'm left with 3x squared minus 17x plus 10. Okay, if you didn't do borrow and payback, try that real quick just to see if you can do it. Okay, try borrow and payback now. All right, so we're trying to factor. Again, I'm going to do borrow and payback. So I'm taking that 3 and I'm putting it with that guy. Then I need to factor that. So Ty, what 2 numbers can multiply to get me 30? X minus 15 and x minus 2. Those 2 things, if you multiply them together, we get him 30. If he added them, it gets him negative 17. So we're good with that. But once I've borrowed that, Kyson, what else do I got to do here? Yes, sir. Divide by 3, divide by 3. All right. So my answers here are going to be 0. Don't forget about that guy. We took that x. That's going to be 0. And then negative 15 divided by 3. Oh, that's negative 5, but I'm going to set it equal. So it's 5 and then a positive 2/3. Those are my 3 answers there. Questions with factoring? Hopefully you're pretty good. But if you've forgotten, I'm helping you. All right, cool. Let's move. Next thing we're doing today is logarithms. So logarithms we really won't see a ton of until second semester, so that's the good news. You also don't have to do a ton of them, but the one section they're in, it's pretty heavy. So you need to know at least the little basics of logarithms. The one thing you do need to know are their graphs. All right. So up on the paper right here, up on the board, I have graphed dropping stuff. I've graphed 3 to the x and log base 3 of x. Which one of those lines is 3 to the x power? Woo. You need to know that. This is an exponential graph. Okay, if you say something is growing exponentially, what does that mean? Growing quickly. This is an exponential graph. It looks like this, where it's going to start flat and then eventually it takes off. That is an exponential graph. Okay, 3 to the x. The opposite of exponentials, the inverse of an exponential function is a logarithmic function. Okay, it does the exact opposite. This right here is log base 3 of x. It starts off going really quickly and then it starts to flatten out. And eventually this line is going to be kind of a flat line over here. One math fact that you need to know, the log base anything, pick a number, it doesn't matter. 7, log base 7 of 1. The log of 1 is 0, okay? Most specifically, we're going to see this one. The natural log of 1, that is 0, okay? It is the opposite of 3 to the 0 power. What is 3 to the 0 power? Anything to the 0 power is 1. That's that point right there and that point right there. When I plug in 1 to the log function, I get 0. When I plug in 0, I get 1 for my y value. That's an important thing to know. All right? If I have an exponential graph, I have an asymptote, a horizontal asymptote at y equals 0. There's a horizontal line right here. Notice that as this blue line goes to the left, it doesn't go underneath. It's always there at 0 and above. There's a horizontal asymptote. If that's true, what do you think the asymptote for this red logarithmic graph is going to be? X equals 0. Good job. It's not a horizontal asymptote. What kind of asymptote is that? Vertical asymptote at x equals 0. Logarithmic graphs always lay in the positive part of the graph. It's always positive. You just got to know some basic things about graphs. Okay, down below, same setup, but instead of 3 to the x and log base 3, we're going to get the one we deal with the most often, which is e to the x and natural log. E and natural log, those two things are inverses of each other. Okay? So when you see natural log of x, it's the same thing as log base e. What is the inverse of natural log of x? I just told that to you. What is the inverse of natural log of x? Just e to the x. That's the opposite. This is natural log of x. It's a logarithmic graph. The opposite of logarithmic is exponential. Logarithmic to exponential. That's an exponential graph here. Okay, e to the x is the inverse of natural log of x. If we have inverses of each other, if I gave you this problem right here, 3x and divided by 3, I multiplied by 3 and I divided by 3. What's going to happen if I multiply by 3 and divide by 3? They cancel. If I gave you x squared and I told you to square root it, squaring something, square rooting, those two things are inverses. What's going to happen? They cancel. So they're inverses. They cancel. If I told you the natural log of e to the x, natural log and e, those two things are inverses. So what's going to happen when I take the natural log of e? They cancel. The natural log of e is just x. What about e to the natural log of x? What's going to happen when I put those two things together? They cancel. E and natural log, they're inverses. They cancel. I'm left with just x. Okay, that's the main thing I need you to know. Know the basic forms of the graphs and know that e and natural logs are inverses, so they're going to cancel each other out. Let's go to the backside. There's some cool rules up here. I can talk through them. You should remind yourself of them. This would be the one that you need to know more than anything. Well, I'm not even going to bring it up. I'll bring it up when we need it. Okay, let's just get to some and see what we can do. So we're going to solve logarithms on the backside. Okay, again, if you can remember that exponentials and logarithms are inverses, you're good. So if I took e to the natural log of 3, well, what's my answer going to be? 3. E and natural log, they cancel. It's 3. 2 to the log base 2 of 5t. What's my answer going to be? 5t, 2 in log base 2. They're inverses. They cancel. That's it. That's all I need you to know. Letter C says log base 3 of 3 to the x plus 2. X plus 2. Log base 3 and 3 to a power, those two things are inverses of each other. They cancel out. Leaves me with x plus 2. Natural log of e to the 4x squared. What's going to be left? Ta-da. It's that easy. Natural log and e, they're inverses of each other. They cancel each other out. We are going to use that skill then, okay, that they're inverses, they cancel each other out, to help solve these last 6 problems. Okay, letter E says natural log of x plus 5 is equal to 3. We are trying to get x by itself. Okay, so think about this if I gave you this problem. Or even better, let's do it this way. If I had this, to get rid of a square root, what would you do? You square both sides, it cancels each other out. We are doing the same thing here. I've got natural log of x plus 5 is equal to 3. I've got a natural log. I want to get rid of it because I want to get x by itself. What is the opposite of natural log? E. So what I'm going to do is I'm going to raise both sides as e to that power. I'm going to raise both sides as e to that power. So on the left side, I've got e to the natural log of x plus 5. On the right side, I've got e to the third. What's going to happen when I've got this e to that natural log? Bye. They go away. I don't need a calculator. Don't type that in your calculator. Just leave it. We leave problems. Here's the number one thing you're going to love most about calculus. You do not have to simplify answers. If you have just numbers left over, you're good. You do not need to simplify in any form. Okay? So if I want to solve this thing to finish, what else do I need to do? Minus 5 minus 5. My answer is e to the third minus 5. Is that a decimal? Sure, but I don't care what it is. I can just write e to the third minus 5 and get full credit. Makes sense a little bit what we did. Let's try again. What do I got? I got a lot of logs. Let's do F. Try it without me. Take a second, see if you can do that problem without me. If you get stuck, cool. I've got log base 3 of 3 to the x is equal to 4. What am I going to do to get rid of log base 3? What is the opposite of log base 3? 3 to a power. So I'm going to raise both sides as 3 to a power. On the left side, that's going to cancel. You might not remember that, but anybody remember what 3 to the 4th power is? 81. Because 3 times 3 is 9. That's 2. Times 3 again would be 27. Times 3 again would be 81. So 3 to the 4th is 81. If you've forgotten that, that's fine. Then I need to solve. What else do I need to do? Divide by 3. X is 27. The opposite of logs is exponentials. Let's try it again. Letter G. Letter G there. E to the 2x minus 4 is equal to 10. E to the 2x minus 4 is equal to 10. I want to get x by itself. Thoughts on what I should do first? Add 4. Get that thing rid of it first, because that's not part of where the x is. This is just added or subtracted on the end, so get rid of it. I'm going to add 4. Now I've got e to the 2x is equal to 14. All right, my x, it's with an e. E to the 2x power, I need to get rid of an e. What's the opposite of e to a power? Natural log. So I'm going to take the natural log of both sides. That's going to cancel. To finish that thing, I want to get x by itself. So what else do I need to do? Divide by 2. It is not natural log of 7. That is not the same thing. It is just natural log of 14 divided by 2. Boom. I don't care what that number is. I could type it in my calculator and get an answer, but I don't need to. That's not how calculus works. We just got that answer right there. Natural log of 14 divided by 2. Okay, I'm going to do one more with you and then see what we got. So let's do letter I. Get solving for I. What should I do first? Add 4. Get rid of anything else. Okay, so I got 2 to the x is equal to 15. I want to get x by itself. Right now it's written as an exponential. Exponential is when x is in your exponent. If x is in your exponent, that's called an exponential function. That's what I got here. What is the opposite of an exponential function? Log. In this case, not natural log because it doesn't have e, but I need log base 2. So I'm going to take the log base 2 of both sides. So on the left side, I've got log base 2 and 2. Make sure you get your work done. That's going to cancel. And on the right side, I'm going to get log base 2 of 15. I don't care what that number is. I'm just going to leave it. Make sense there? Try one last one. Try letter H. Divide by 2 first, because you can't mess with that 2 in front until you, or you can't mess with the E until you get rid of that. Last one. Letter H, 2e to the x squared is equal to 106. We're trying to solve that thing. Taylor, what'd you do there? Divided by 2. Get rid of that 2 in front because we don't need that as part of our problem. So divide by 2. Divide by 2. I'm left with e to the x squared equals 53. Yeah. Then what? Yes, you took the natural log of both sides. Yep, same idea. Take the natural log of both sides. Natural log and e cancel, leaving you x squared is equal to the natural log of 53. We take the square root, take the square root. This gets a little bit funky. The natural log of 53, we need one more thing. Plus or minus. I take a square root, I'm going to have plus or minus there. Is that super ugly? Yeah, it is. But the problem wasn't. We just did the same steps. We went this step, this step, this step, done. Okay, don't let it be overwhelming to you.